Hey everyone, welcome back to yet another episode of GenAI Vlog. Today, we're going to be discussing a quick way or an efficient way of creating a neural network model to classify fake news using the OpenAI embedding layer. So first things first, you import your libraries, and then you need a data set. Here, I already have a template data set that's called data.csv. You can essentially create this using any Excel spreadsheet with essentially two columns. One is called label, and the other one is called text. The text has news copy from Reuters or Wall Street Journal, places like that, and then you tag a correct label to it. So that is your raw data. For simplicity, I'm just going to use 500 rows randomly selected to create a smaller data frame. I'm going to call that df small. And then we can verify the label is about 51%, meaning that the real news and the fake news are equally distributed. So with that being said, this is how I process the data. And the first things first is I need the API endpoint from OpenAI to create the embedding layer. So what that means is I set up my OpenAI API key, and then I create this function that sends the text into this API call. And I use this model embedding ADA002 to create the word embeddings for this text that I sent. Now, this helper function is created, and then I can loop this helper function through this small data frame by calling the text. So effectively, what it's doing is it's going to take this text column and it's taking whatever it's in there and convert that into a vector of numbers. So this is the output of the embedding layer coming out of this model of my choice. And with that being said, now I can work with numbers. I can build a classifier, things like that. So what's happening here is I then can extract the value, create my X, these values are the features, and then I can create my Y value, that's the label, which is also the correct ground truth. And then you essentially get this data frame of 500 rows and 1,536 columns with the correct label attached to it accordingly. Now we need a model. So we use TensorFlow to build a simple neural network model with pretty much three layers. Each layer you can create a batch normalization using ReLU to activate it. So these are all simple design. The only thing I need to be aware of is the input layer needs to accept 1536 as the input dimension because that is the dimension from the dataset. And then the last layer also has one neuron because the Y, the label here, has a length of 500 and that's just one vector. So this last dense layer needs to have one neuron. And then you can activate it with a sigmoid function. So this operation mimics the design of a logistic regression model in the sense that it gives you a probabilistic outcome. So with that being said, you wrap the model together in a model object, compile it, and then you can print out the summary, and that's your model. So with the model being designed, then you can, of course, train it. So you use model.fit, throw X in there, throw Y in there, and you'll be able to see this kind of performance. I think I repeated this a couple of times, so altogether we might be talking about 50 to 70 epoch, and you'll be able to get a decent performance with the accuracy of the training set being 100% and the validation set being 98%. And then, of course, you can make a prediction. You can pick a cutoff, let's say 0.5. You can flatten it and then generate some sort of classification report. This classification report will be able to calculate a variety of different metrics, such as precision, recall, F1 score of each particular class. And then on average, you can visualize the performance just like that using this table to make your life easier. And since this performance is actually already hitting 100%, so it's not that bad. Perhaps I want to save it. Perhaps I want to push it onto the HuggingFace cloud. So the way to do that is to download these packages using the CLI logging. I already entered the key and token so that I have the login credentials entered in there so that I can access the HuggingFace cloud. So I use the push to hub keras function to push this model to this directory. Once that's done, it will be able to give me this URL. So I can click in there and go into model card. This is what the model card look like. I haven't really filling a whole lot of these information. So for now, I'm just going to leave it as a blank. But if you go to files and versions, you'll be able to see that the weights are here along with the variables. And then you can, of course, use this model by clicking this button, so on and so forth. For the sake of simplicity, in this demo, I'm going to make an inference by just calling this from pre-trained keras function by putting the directory of where the model is. And this directory comes from the name that's coming from this model online. So grab this path, put that in here. You'll be able to load this model directly from the cloud to your Python environment using one line of code. And then here, what I noticed is you want to convert your data into flow32 to actually feed this into the reloaded model. After that, you can convert that into NumPy array, and then you are all set. You can generate the classification report just like we did above and be able to see the same performance. So with that being said, hope you like this video. Hopefully this video sheds some light of how to take any random CSV to acquire OpenAI endpoint, to build your embedding layer output, and to loop that through every single text of your data frame, and to build a TensorFlow model, and to train it, and eventually to visualize the performance. And last but not least, we also discussed how to push this to the HuggingFace cloud. Thank you for watching. Subscribe and like.